Welcome back, class 9, to the online chemistry classes. Already we have started the summary of the chapter 1 before your test, and you have already finished writing the test also. Now I will just go through some of the portions of chapter 1, then the 2. In the previous class we had done what is molecular formula. Already we had done molecular formula is the one which represent one molecule of a substance, like H2O is one molecule of water, in which two atoms of hydrogen combines with one atom of oxygen to form one molecule of water. Similarly, what is valency? I had said valency is the combining capacity of an atom. It is the number of electrons which are lost, gained or shared by atom of an element to complete its octet. What is octet? Octet means to have 8 electrons in the outermost shell to become stable. All the elements try to achieve their octet or deplete, like in case of helium, which has only 2 electrons in the outermost shell. It will try to complete the number of electrons in its outermost shell. Then we studied about radicals or ions. The charged particles are called radicals, and radicals is a group of atom or a group of atom with some charges on it, like carbonate, CO3, sulfate, SO4. They are radicals. Different radicals have different types of charges on them. Nowadays, radicals and ions are considered different. What is ion? The charged particles are called ions. So it is not in the scope of this syllabus to study the differences between radicals and ions. Now, what is monovalent, divalent and trivalent? Monovalent means having a single valency. Divalent means those radicals which has two valency, like carbonate. You can see CO3, this is the formula of carbonate, 2 minus. It has two valency but negative valency. So this is called divalent. If 2 positive also, then also it is called divalent. Positive or negative, the charges doesn't matter. If valency is 2, it is called divalent. If it is 3, like in case of aluminium, it is called trivalent. If 1, it is called monovalent. Then we studied about variable valency, that elements which show different types of valency, like iron has ferrous, ferric, 2 types of valencies, 2 also, 3 also. Mercury also 1 valency and 2 valency also. Now determination of formula from valency. How to write the formula? Example, if you say carbon dioxide, this is the formula of carbon dioxide, you know. If you know the valency of carbon is 4, valency of oxygen is how much? 2. So using this valency you can write the formula, like carbon, oxygen. What is the valency? Interchange it. Like oxygen valency is 2, so write it here. Carbon valency is 4, so write it here. These 2 and 4, both of them will cancel by 2, 2 1 are 2, 2 2 are 4. That will give you the formula of carbon dioxide as CO2. Got it? Like this, in case of water also, if you need to write the formula, molecular formula of water, if you know the valency of hydrogen and oxygen, you can write it. Hydrogen valency is taken as 1, oxygen valency is taken as 2. So when we write water molecule formula, hydrogen valency 1 is kept here and oxygen valency 2 is kept here. Okay? So we get H2O1, 1 no need to write, that is H2O. Understood now? Okay, now next we have to do is the estimation of valency from a formula. If a formula is already given, you can estimate or find out what is the valency of those elements which are present in it. Like one example, you can say, if I write MnO2, see I am writing manganese, Mn for manganese dioxide. Okay, this one Mn stands for manganese, not magnesium. Magnesium is Mg. And O2 for oxygen. Manganese, di means 2, oxide, that is oxygen. So here manganese and oxygen, 2 different elements are there. What are they? Manganese, Mn, and oxygen. Now, what is the valency of manganese? What is the valency of oxygen? You know that valencies are interchanged. Interchanged means if I suppose write here X and Y, the Y valency will be here and X valency will be kept here. Okay, interchanged. So here it means this nothing is here means 1 and here 2 is there means it is the valency of which one? Manganese. Okay, so it means manganese has a valency of 2, oxygen has a valency of 1. No, it's not like that. You know that oxygen valency is 2. Then manganese valency will be how much? If it is 2 here already, if I write here 2, it means here it should be 4. Then only it will cancel and the answer will be MnO2. Okay? MnO2 means Mn2 and O4. That is manganese valency is 4, oxygen valency is 2. In your book also it is given. You can write it and understand how it is done. Like MnO. It is written here 2 valency on the top, 1 here. Okay? Now if you want to multiply both of them, the valency of oxygen is 2. Hence, you have to multiply, here it is given 1 only, but actually valency of oxygen is 2. So multiply both of them by 2. So what you get? Mn 2 to the 4 and oxygen 1 to the 2. It means manganese valency is 4, oxygen valency is 2. Okay? Got it? Now next we have to do is naming a compound from the formula. Different rules are used for naming the compound. First, steps to write the name of the compound. Identify the cation and anion in the formula. Okay, which one is positively charged, which one is negatively charged. Write the name of the compound in the same order of radicals as it is given in the formula. Like if you have tried the formula of sodium chloride, Na, sodium symbol, and chlorine or chloride symbol is Cl. So NaCl is the formula for sodium chloride, which is the name of our common salt. Okay. Now how to name the acids and bases? Already you have done. What are the rules for writing of chemical equation? What is a chemical equation? Last time also I had said chemical equation represents the reactants and products in a reaction. Like if I will write here C plus O2, they are the reactant side, left of the arrow, and the one which is formed here on the right hand side, suppose CO2 is formed, then we say this one is product, these are the reactant side. Okay. Now what is the chemical equation? Chemical equation is the symbolic representation, means using the symbols like carbon symbol is C, oxygen symbol is O. So symbolic representation of reactants and products is called a chemical equation. So this one represents a chemical equation. Now what are the rules for writing the chemical equation? Number 1, left hand side represent the reactant side, right hand side represents the product side. The arrow in the middle indicates the direction in which the reaction proceeds. Like if the arrow is like this, it is called reversible reaction. Means the reactants can change into product and the product can once again change into the reactants. Okay. Then number 2, double arrow, already I said, a sign, if like this sign is given above the arrow, that means it indicates that heat is absorbed in the reaction. But if some sign is there like this arrow after the product, it means the gas is evolved. Okay. Then next one is what are the different types of chemical equation? One is a skeletal equation, a equation which remains unbalanced, like that is the raw equation which remains unbalanced is called a skeletal equation. So equation which represents the chemical change but is unbalanced is called a skeletal equation. Like I will write here silver oxide Ag2O plus silver oxide dissociate or break down into silver and oxygen, Ag plus O2. Now check whether it is balanced or not. Here 2 silver, here only 1 silver atom is there. Here 2 oxygen atoms, here only 1 oxygen atom is there. It means this equation is not balanced. Such a chemical equation which is not balanced is called a skeletal equation. Now what to do if we have to balance it? We have to make them equal on both sides. Like here silver is how many? Ag means silver, the symbol, okay? 2, here oxygen, how many are there? 1 atom. This side, on the product side, silver how many? 1, and oxygen how many? 2. So see, here oxygen is 1, in the product side oxygen is 2. So we have to make it 2. To make it 2, we have to write 2 in the front. We cannot write or add any number here at the base. So we have to write only in the front as prefix, okay? If you write this 2, now the number of atoms of silver Ag will also change. That is 2 into 2, it becomes 4. Now here silver is 1 only, so we have to make it 4. To make it 4, we have to write 4 here in the front. Okay, 4 silver atoms, and oxygen is 2 already given. So now the equation becomes balanced. And this method of balancing of chemical equations by choosing the number and trying it with different numbers is called hit and trial method of balancing equations. Now, what are the methods of balancing equation? 2 methods are mentioned in your book. Hit and trial method, the one which we did just now, the one which we have to follow, and the second one is partial equation method, which we have to learn in higher classes. So now I will show you one example of balancing of equation. Okay, now you can see one equation is given on the board and question is to balance it. Now see, there is an arrow in the middle. To the left of the arrow, all these are the reactant side, and right side of the arrow, they are known as product side. So what you have to do, first draw a line. The method of balancing, already you may be knowing, it's already taught. We have to write down each and every elements like Fe, that is the symbol of iron. How many are there? 1, so write 1. Then Cl, that stands for chlorine. How many are there? 3. We have to see this side also. Like if some atoms are present on the right hand side, not right side the arrow, means to the left of the arrow we have to count all of them. Like 1 oxygen is here, 2 are there, then we have to add both of them. Okay, so here chlorine is only 3 are there, so we have to write 3 atoms of chlorine. Then we have sodium, that is Na. How many are there? Only 1 atom of sodium, so write 1 here. Then we have oxygen, O. How many are there? Only 1 O is there, this side no O, so 1. And then hydrogen is also there. How many? 1. So iron, chlorine, sodium, oxygen, hydrogen. These 5 elements are there. 1, 2, 3, 4, 5. The same elements we have to write this side, that is to the product side. Fe, Cl, that is chlorine, Na, that is sodium. Then we have O, that is oxygen, and H, that is hydrogen. And count the number of atoms of each element present to the right hand side. Like let's start with iron, Fe. How many are there? 1. Nothing is there means 1. Now Cl. Cl is here, only 1 is there, so write 1. Sodium, only 1 atom is there, so write 1. Oxygen, Cl. OH is given within the bracket, and outside the bracket the number 3 is mentioned. It means there are 3 oxygen atoms and 3 hydrogen atoms. This 3 is for both oxygen as well as hydrogen. Means 3 oxygen and 3 hydrogen. So we have to write 3 oxygen and 3 hydrogen also. Okay, so this is our unbalanced equation. Now you can check 1 1, 3 1, 1 1, 1 3, 1 3. It's not balanced. If the equation is balanced, the numbers should be equal on both sides. So let's start with first one, that is iron. 1 1. It's already balanced. Chlorine 3, and here chlorine is 1. It means not balanced. We have to make 3 chlorine atoms on the right side also. Here we have to make 3. But what we have to do to make it 3? This side chlorine is here, means you have to write 3 here in the front. Okay? You can write any number here. Don't write any number here. Okay? It's not allowed to write as like at the base. You can write in the front near the prefix. Okay? As prefix. So if you write 3 here, now the chlorine becomes 3, but it changes the number of sodium atom also. Now sodium atom becomes 3 because of this. Because this 3 is for both sodium as well as chlorine atoms. And here this side you see sodium is 1 only, this side. In the product side it became 3. So we have to make this side also 3. To make it 3, I have to write 3 here. Okay, now sodium became 3. Now the number of oxygen atoms, 3. So here oxygen atom is changed to 3. Number of hydrogen atom also became 3. So let's take it once again. 1, 1, 3, 3, 3, 3. Yeah, all balanced. It means now the equation becomes balanced when we write these 3 here and these 3 here. Understood? So you have to practice yourself at home to practice more and more balancing of equations so that you can learn it. And then the next topic which is there is how to find the molecular formula, percentage, mass and all, determination of molecular formula. How can we find a molecular formula? Okay, and what are the steps of finding? But before that, what is relative atomic mass? Already you have studied. Relative atomic mass is mass of one atom of an element divided by 1/12 of the mass of carbon 12 atom. Then what are the informations conveyed by chemical equation? What are the limitations of chemical equations? You have to learn it. Then what is formula? Formula is a symbolic representation of a molecule of a compound. Like H2O is the formula of water. CO2 is the formula of carbon dioxide. Okay. What is empirical formula of a compound? Empirical formula is the formula which gives the number of atoms of different elements present in one molecule of the compound. Okay. Like for hydrogen peroxide, the empirical formula is HO. This is the formula of hydrogen peroxide, H2O2. This is the formula of hydrogen peroxide. Its empirical formula means what all elements are there? Hydrogen and oxygen. So this one is called the empirical formula. Since all these are already taught, so you can easily do it. Okay. So today up to here, in the next class we will study about chapter 2, chemical changes and reactions. I'll just give a review and then I think this chapter is also taught, but still I'll give a review of chapter 2 and then we'll move on to the next chapter. Thank you.